Good morning everyone. Welcome back to the another session, and this video is about binary tree. This video is about binary tree. Now let's look into this. A part of this video we'll talk about what is binary tree and types of binary tree. This video will cover these two concepts. Okay, now let's look into what is binary tree. Binary tree, the name itself it tells. Binary means two. Binary means two. Tree is what? Tree is a non-linear data structure. Tree is a non-linear data structure where the nodes are arranged in a hierarchical fashion. This is what without a closed loop. This is what a tree is. Now we are going to talk about binary tree. Binary means two. So the definition of a binary tree is a tree is called as binary tree when the maximum number of nodes, the maximum number of children nodes are at most two. The maximum number of children nodes for one node at most two. That is maximum two nodes. Maximum two children nodes. Maximum two children nodes. Maximum two means what? It is maximum two, 1 or 0. This is a binary tree. Binary tree is called as a tree is called as a binary tree when it is having at most two child nodes. A binary tree can consist of at most two children nodes. Binary tree. A tree is called as binary tree when it have at most two children nodes. Example. Now see, now I have a tree. I told you that a tree is called as binary tree when it have at most two children. So A is a parent node and A is a root node which has to maintain two children nodes. At most two children nodes. So A, B, A, B, C, D. So in this is called as a binary tree because A is my parent node, A is my root node which is having two children nodes. This is one children, B is one children, C is the other children, two children nodes. And B is again my node, C is also again my node. So where B doesn't have any child nodes. So the definition is what? Maximum of 2. So it can have even 0. Right? It can have even 1. It can have even 2. So as far as the definition is concerned, B doesn't have any children. But still we can call it is a binary tree. Right? Now look at this. A is my parent node. B is also my node. So A is having one children node. So it is a binary tree. Now look at this. Binary tree. Binary tree. Now look at this. A is my node which is having three children. So the maximum is only two children. Maximum is only two children. If a tree is said to be binary tree, it should maintain maximum of two children. As it is maintaining three children, it is not a binary tree. Okay? Right. Now, let's look into Type of binary trees. Types of binary trees. The one is fully binary tree, or strictly binary tree. And the second is almost complete binary tree, or incomplete binary tree, or incomplete binary tree. And the third is complete binary tree, or perfect binary tree. And the next is skewered tree. Left skewered tree, right skewered tree. And the fifth is extended binary trees. Right, now look at once types of binary trees. Fully binary tree, or strictly binary tree, almost complete binary tree or incomplete binary tree, complete binary tree or perfect binary tree, left skew tree, right skew tree, extended binary tree. Let's discuss one by one. Fully binary tree. Fully binary tree. Every fully binary tree, every node must have two children except of leaf nodes. Every node must have two children except of leaf nodes. Example: A, B, C, D, E. Right, now look at this. I'm drawing the other tree. A, B, C, D, E. A, B, C, D. Right, now look at these trees. There are three trees. Now, how many nodes it is, how many children each node is having? Let's see it. As for the definition, every node must have two children. So A is my root node and it is having two children. B is one and C is the second children. So condition satisfied, definition fulfilled. Now B is my another node and it is having two children nodes. Yes. And C is my another node. So C is my leaf node also. Right? Look at this. C is my leaf node. D is my leaf node. C is my leaf node. D is my leaf node. Now what is leaf node? Leaf node is the node which doesn't have any children. To understand the terminologies of trees, already we made a video named tree terminologies. So I'll be providing the link in the description for three terminologies to understand what is leaf node, what is parent node, what is child node. This you can see that video for the better understanding. Right now these are leaf nodes. So what is the definition? Every node must have two children except of leaf nodes. So except of C, except of D and E, every other nodes are having two children. So this is called as fully binary tree. Now look at this. A is my node, A is having two children. B is my node, B is not a leaf node, whereas B is having only one children. So this is not fully binary tree, but it is a binary tree. Understand the difference. It is not fully binary tree, but it is a binary tree. Now look at this also. A is my node, is having two children. Okay. B is my another node. It should have two children because it is not leaf node. It should have two children, but it is having only one children. So it is also not fully binary tree, whereas it is a binary tree. Understand? And let's see the second one, incomplete binary tree. Incomplete binary tree or almost complete binary tree. Now let's see. Every node must have two children in all the levels except in last level, and elements or node values, or node values filled from left to right. Every node must have two children in all the levels except in the last level, right? Except the leaf nodes. But there is a condition here, which is elements or node values should be filled from left to right. Now let's see the example. A, B, C, D, E, F, G, H, I. Now look at this. This is incomplete binary tree, or else it is almost complete binary tree. Now A is my node, which is having two children. It should have two children. It must have two children, right? B is also having two children. C is also having two children. D is also having two children. Except of last level. What is the last level? H is not having. I is not having. And if you see here, element has to be, if I wanted to insert a J, J first of all has to be filled from left to right. So J should be actually available at left side. Instead of placing right hand side, or instead of placing right child of E, it has to be placed left child of E. That is what? Elements or data nodes filled from left to right. So by leaving left position, we should not go for right position. This is what incomplete binary tree or almost complete binary tree. So it is a binary tree. It is a binary tree, but it is not incomplete binary tree, because element has to be filled First of all left, then it should go to the right. So left place is vacant here and right place is filled. So it is not incomplete binary tree. Now let's see the third category. Complete binary tree. Third category. Complete binary tree. Complete binary tree. Complete binary tree also, every node must have two children. Every node must have two children, and at every level, at every level of complete binary tree, there must be two level number of nodes. Two level number of nodes. For example, at level 2, there must be 2 power 2 is equal to 4 nodes. And at level 3, there must be 2 power 3 is equal to 8 nodes. 2 power 3 is equal to 8 nodes. In complete binary tree, exception is given for leaf nodes. Exception is given for leaf nodes. Now let's see the complete binary tree. A, B, C. So it is what? Every node must have two children. Every node must have two children. Now, every level of complete binary tree, there must be two level number of nodes, right? Now let's see. Now what is a level? Now level A is 0, right? A is a root node. The level of A is 0. To understand what is level, what is height, what is depth, the tree terminologies, please kindly go through the tree terminologies video that is available in the description. Okay, level equal to 0. Now this is what level is equal to 1, and this is level is equal to 2. Now let's see how many nodes should a complete binary tree have in each level. So as the level is 0, now 2 power 0 is equal to 1. So in the level 0, as far as complete binary tree is concerned, in the level 0, it should have one node. In the level 1, it should have two nodes. In the level 2, it should have 4 nodes. This is what your complete binary tree. So I said that exception is given, right? A, B, C, D, E, F, G, H, I. Still it is called as complete binary tree. Still it is called as complete binary tree. This is last level. Last level exception is given, right? So this is your complete binary tree. And the next is skew. Skewed tree. Left skewed tree. That is, the nodes in a tree will be arranged in the left hand side. The nodes of a tree will be arranged in left hand side. That is called as left skewed tree. Right skewed tree is the nodes of the, the nodes in a tree will be arranged right hand side. Arrangement of nodes in left child as left skewed tree. Arrangement of nodes in right child, that is right skewed tree. And the last category, extended binary tree. Extended binary tree, that is a binary tree can be converted into full binary tree by adding dummy nodes to existing nodes wherever it is required. Right. The reason to write the complete definition is this video will be viewed by many engineering students, right? So you will be asked in the examination to write 2 marks answer. So in that regard, I am trying to put the answer here. So it is for your convenience. Extended binary trees. A binary tree can be converted into full binary tree. How will be converting into fully binary tree? By adding dummy nodes to existing nodes wherever it is required. Let's see the example. Now the example is, I have a binary tree. Can I call it as a binary tree? Yes, I can call. Why I can call? A binary tree condition is what? It should have at most 2 children. Right? That is, it can have 0, it can have 1, it can have 2. Now what is fully binary tree? It must have 2 children. So to equalize binary tree to fully binary tree, we need some extra nodes, because it should have 2, it may have 0 and 1. So look at this one, you may have 1. So to balance to this level, you need to add some dummy nodes. Now look at this, A, B, C. Now as B is having only one child, which is D, I am making by putting a dummy node. This is my dummy node Dn. Okay. Now see this one, see this tree. Now it is looking like fully binary tree. So this is what your extended binary tree. I am marking this. It is not I am striking off. I am marking this is a dummy node for your reference. So this is your dummy node to make a binary tree into a fully binary tree, or else you can make a complete binary tree also, because for complete binary tree also we need 2 children. Must have 2 children. So when you have a binary tree, you can convert that into fully binary tree, complete binary tree by adding some extra nodes. That is what your extended binary tree. Now let's look into today's portion. What we were discussed is this. We were discussed that today our concept, this video is covering what is binary tree, And types of binary trees. Types of binary trees. Now this is what your fully binary tree. And this is the explanation and the example for incomplete binary tree. Incomplete binary tree. And this is complete binary tree. And this is skewed tree and extended binary tree. So this is your example. Okay, right, thank you all. Next video will be going to do it on implementation part of binary trees. Thank you all.